Good morning, everyone. How are you guys doing today? So, I already posted the review sheet for our exam file on Brightspace. If you haven't noticed that, our next exam and the last in-class exam will be May 9. Is May 9, right? Let me just make sure. Yep, May 9 means 2 weeks. In 2 weeks, you're going to have your next exam. And like I said, it will be on Inter chapter 10 and 11. So what I would like to ask, from all those questions you have in your exam, I'll ask you a question from these. And then we finished chapter 10.5, section 10.5 in our last class. We are still doing 10.6. Then my plan is to finish 10.7 today and tomorrow. And then next week, we are going to do chapter 11. So we have 4 classes for chapter 11. And then you're going to do a review, and your exam will be Friday in 2 weeks. Okay, so this exam will be long, but it will not be anything, any surprises. For your final exam, you have 2 hours 30 questions. So for 1 hour class, you're supposed to have at least 15 questions. But I give you more than 1 hour. I give you almost 1.5 hours, right? If you notice that. So I'll give you around 20 questions on this, which makes sense because in the final exam, you have to do 30 questions in 2 hours. So in 1.5 hours, you should do at least 20 questions. So from here, it will be around 16 to 20. Any questions? No? Okay, then what we did in our last class, we started doing, we started solving radical equation. And the first condition to solve radical equation is that our radical term has to be alone in one side. So anytime you have anything next to the radical, either in the front or on the right side, if you have anything, your first step should be getting rid of that. Once you get rid of everything next to the radical, then you can apply the square power. Not square, depending on what type of radical you have. Here we have square root, so you apply square power. If you have cube root, you need to apply cube power. If you have fourth root, you need to apply fourth power. So depending on what type of radical we have, we apply that power. And for square power, we have x minus 2 on one side, but we cannot distribute the square to x and 2. Instead, we have to FOIL them out. Square tells us that we have x minus 2 twice. So when you FOIL them out, you get a quadratic equation. Once you get a quadratic equation or any equation that has a power more than 1, the highest power, bring everything to one side because our goal is to factor. Once you bring everything to one side, you factor and then you solve. But radical equation has a problem. We cannot just accept the answer we get after solving because sometimes one of the answer doesn't work, or both of them don't work, or both of them work. Okay, so we have to check which scenario is this. Do you have one solution, 2 solution, or no solution? So you must always check into the original one with the radical sign. You cannot substitute that into the quadratic equation. It doesn't make sense. You must always substitute in the original one. And see here in this question, x equals 5 worked, but x equals 1 did not work. The left side and right side, they did not give us the same number. So let's do one example with cubic root this time. What is our first step here? Question number 1, is our radical term alone? No. So what is our first step? Get rid of the 4. Or you can add the radical term to both sides because this is negative. So either you can subtract 4 or you can simply add these to both sides of the equal sign. If you do that, the positive negative cancel out. Now we have cube root of x minus 8 alone in one side and 4 alone on the other side. Is our radical term alone now on one side? Yes, it is. So we can apply the power on both sides. Which power is supposed to apply now? Cube. Good job. So cube root, cube power cancel out. We get x minus 8. And what is 4 cubed? 4 times 4 times 4. 64. What's next? What do we do to get the epsilon? Add it. So we have x equals 64 plus 8. 72. Now for add root, we don't actually have to check the answer because add root gives us the real solution. For even root, we have a problem. But just to have the habit of checking, I'll check here. We have 4 minus cube root of x minus 8. The result has to give us 0. So we have 4 minus cube root of 72 minus 8. So we have 4 minus cube root of 64. 4 minus cube root of 64 is 4 because 4 cube is 64. And 4 minus 4 is 0. So we do have same number. So usually for odd, it will always work. For even, we have a problem. It's because odd root, they have domain all real number. Means for every x value, it works. But for even number like square root, fourth root, sixth root, our domain is not everything. It's a specific interval. That's why the solution we get, it has to lie inside the domain. That's why you have to check if the solution we have, do they fall inside the domain or it's outside the domain? I have 3 questions for you. Try them. Wow, today everyone is kind of surprised when we had really fast steps. Both of you are at the same time. While you're editing class is CTFA. Are you allowed to distribute the file when of course not, there's the root right this time. You have to boil the the owner is access to the file. He is the no. So if it's a long video, it's like I want to check the file. If the initials are on one side, then you can like stop. What's the carefully? What's the name of the sample? Most are roots. Which we want and we want to look at. It's yeah. That's why we like to go. This is a call up for someone. I'll give you 2 more minutes, okay? Whatever you can do in 2 minutes, go ahead. And you guys should learn how to work faster. Final exam has 30 questions, only 2 hours. So if you cannot finish everything in all 30 questions in 2 hours, you'll be in trouble. Okay, let's do them. For A, our radical doesn't have anything next to that. Not on the left side, not on the right side. So when the radical is alone, it's very weak. And when it's weak, we can kill the radical by applying its power. Square root means we have to apply square power on both sides. So the radical and the square power, they cancel one another out. So we get 2x minus 3 without any radical. And common mistake I noticed that you guys distributed the power, but you're not allowed to distribute the power when you have addition and subtraction. You can distribute the power in multiplication, division, but not addition, subtraction. Addition, subtraction means you are going to multiply the same base power many times. Our power is 2, so you need to multiply x minus 3 twice. And then you can use FOIL. You get x squared minus 6, x squared minus 6x plus 9. And then you subtract everything from one side so that they all gather around on one side. So you subtract 2x from both sides, add 3 to both sides. So the left side becomes 0, and we want to see 0 because you're solving. And on the next side, we have x squared minus how many x's? 8x's plus 12. And that was our goal. Huh? It's 3, my bad. See, I added 3 on one side. Come on. I added 3 on one side, 9 on the other side. I don't know why. So 9 and 3 gives us 12. And our goal is to get this so that we can factor. It's a quadratic equation. So in this class, all of them will be factorable. So here you get x squared minus 3x plus 9. So minus 3 gives us minus 6x. Here we have positive 2x. So if you want to move this positive 2x, you need to subtract. So minus 2x both sides. So minus 6x minus 2x minus 8x. But good question. Thank you. Now, what two numbers multiply to 12 combined to negative 8? Negative 6, negative 2. We are happy with the factors. So next step, we solve them. X minus 6, 0. X minus 2, 0. We add 6 to both sides, and we add 2 to both sides. That gives us x equals 6, x equals 2. But just because I got them, it doesn't mean we can stop. We must check whether they are correct or not. So we go back to the original equation, square root of 2x minus 3. The result has to give us x minus 3 for both cases. 2x minus 3, the result has to be x minus 3. So in the first term, our x is 6. In the second term, our x is 2. So we get 2 times 6 minus 3 equals 6 minus 3. Here, 2 times 2 minus 3 under the radical should give us 2 minus 3. Now, since I don't have space, so let me do it shortcut. 6 times 2 is 12. 12 minus 3 is 9, right? So we have square root of 9. What is square root of 9? 3. And on the other side, you have 6 minus 3. What is 6 minus 3? 3. Do we have the same number on both sides? Yes. So we accept x equals 6 as our solution. Now for the next one, we have 2 times 2 is 4. 4 minus 3 is 1. So we have square root of 1, which is 1 on one side. And how about the other side? 2 minus 3. -1. Do we have the same number on both sides of the equal sign? No. So you cannot accept this as our solution. So the only solution that works is this one, x equals 6. X equals 6. The next one is a radical term alone on one side? No. So what is this bodyguard? Which one we have to move? 4, so we subtract 4. Anything we have next to the radical is its bodyguard. So first step, you have to move all these bodyguards so that you can kill the radical using its power. But you cannot apply the power if you have any type of bodyguard next to your radical. So we have 3 minus x, sorry, 3x minus 8 on one side, and the other side we have x minus 4. Is a radical term alone now on one side? Yes. So we can apply the power. Which power we apply? Square, because we are dealing with square roots. So square power, square root cancel out. We get 3x minus 8. Same thing, the other side, we cannot distribute the power. Instead, we have to FOIL them out. So when you FOIL, you get x squared minus 8x plus 16. What do we do next? We need to bring the 3x and negative 8 to the other side. So we subtract 3x, but add 8. So everything cancel out on the left side, we get 0. And on the other side, we have x squared minus 11x plus 24. So it becomes quadratic equation, just like the previous one. And we love quadratic equation because we can factor them. Not every quadratic equation, but whatever we have in this class, for this section, it's factorable. Two numbers multiplied to 24 combined to -11. What are they? Go ahead, Miley. -8, -3. 8 times 3 is 24. 8 plus 3 is 11. So, yep. We have x minus 8 equals 0. X minus 3 equals 0. So, we get x equals 8 and x equals 3. Two solutions. But just because we got them, it doesn't mean they're correct. We go ahead and check both of them. 3x minus 8 plus 4 has to give us x back. And we have to do it twice. Oops. Square root of 3x minus 8 plus 4. In the first one, our x is 8. So every x you see, you replace with 8. In the second one, our x is 3. So every x you see, you replace with 3. So we have 3 times 8 minus 8 under the square root plus 4. The result has to be 8. Here 3 times 3 minus 8 under the radical. And if you add 4, the result has to be 3. 3 times 8. What is 3 times 8? 24. So 24 minus 8 under the radical and then plus 4. What is 24 minus 8? Come on, guys. 24 minus 8? 16. And what is square root of 16? And what is 4 plus 4? Do we have the same number on both sides? So we accept x equals 8 is our solution. The next one, 3 times 3 is 9. So we have 9 minus 8 plus 4. 9 minus 8 is 1 plus 4. So we have 1 plus 4. And what is 1 plus 4? Do we have the same number on both sides? So we cannot accept x equals 3 as our solution. So the only solution we have is this one. Any question? Now the last one, we don't have anything extra. We have two radicals on two sides. Since at least one radical is alone, so we are allowed to apply the power on both sides. As long as one radical is alone, we can apply it. So the radical and power cancel out. We get 8x minus 3 equals 3 minus 8x. And then what? So we can add the 8x. And you also want to subtract, okay, no problem. Minus 3, minus 3. You don't have to do that. So you have 16x minus 6 equals 0. Add 6. So 16x is 6. Divide by 16. 16 and 6, both of them are divisible by which number? 2. So we can reduce both of them by 2 and we get 3, 8. Okay, space now. So let me do the checking here. Square root of 8x minus 3 equals square root of 3 minus 8x. So we have 8 times 3 over 8 minus 3 under the radical. 3 minus 8 times 3 over 8. We have 8 in the numerator, 8 in the denominator. We can cancel them. 8 in the numerator, 8 in the denominator. We can cancel them. So what is left then after we cancel the 8? 3 and we're subtracting 3. 3 and we are subtracting 3. Do you have the exact same thing on both sides? So you don't have to go any further. As when you see the same two things, you can stop. So yep, we accept this solution. This is correct. And that's how we solve radical equation. In the final exam, there will be at least one. And in the in-class exam, there will be one, definitely. Any question? So let me tell you. Oh, not here. If you look at the review sheet, what do you expect? Definitely all of them. Well, I can't write here, never mind. Definitely all of them. And then one from 10.5, one from 10.6. Okay. And now we are going to do 10.7. Definitely one from each. One from 3, one from 4, one from 5. So these are the main topics on 10.7. How do we work with imaginary numbers? So let's start. Imaginary numbers. Imaginary numbers have another name, complex numbers. Complex numbers and imaginary number are the same thing. It means they are not real. So let's review an example, x squared plus 1. In order to get the epsilon, we need to subtract 1 from both sides, so we get x squared equals -1. And into the square root, we get x equals square root of -1. And we already know square root of -1 doesn't exist in the real life because there is no number you multiply twice and it becomes -1. So that's where the imaginary number comes from. When we cannot get them as a real number, we look at the imaginary world and see, can we find something that is suitable for this number? And then, yep, mathematician found a notation called I for square root of -1. Square root of -1 is 1, but not a real 1. It's imaginary 1. So we indicate that with I. I is square root of -1. And when you multiply square root of -1 twice, it becomes a real number, -1. So I is square root of -1, but I square is real number, -1. These are the main characteristic of the imaginary numbers. Now, how do we write them? Let's say we have a negative number under the square root. First step is we split them into two pieces. One is with -1 and one is with the real number. The real number we know what is that. We just write that down, whatever that is. If it's a perfect square number, we get a number back. If it's not a perfect square number, we keep our radical. But that imaginary number turns into the imaginary number I, which is 1, imaginary 1. For example, if we have -16 under the radical, we can split that into two pieces. Square root of -1 times square root of 16. Because square root of 16 is square root -1 times 16. So you can split them. And then this portion gives us I because this is not real. And how about square root of 16? Do we know what is square root of 16? 4. So we get from here. And when you have a whole number, we're supposed to write the whole number first and then the imaginary number. But when you have a radical number, write the I first and then the radical number. Actually, the position of the I doesn't matter, but my math lab prefer, if you have a radical, put the I first and then the radical. But for whole number, write the whole number first and then the radical. So enough radical, I. Any questions so far? The next question, it has double negative. What's the role for the first negative? What do we do with the first negative? Multiply. It's negative times square root of -1 times 9. So anytime you have a negative in the front, what do we do? Do you remember? We just carry it down. Because it's a multiplication, just like coefficient. You bring it down to the last step. So we keep our negative, but we split this into two pieces. One is square root of -1, and one is square root of Positive. This is a multiplication, so we bring it down. And how about this one? I. Because this is not real, it's imaginary. And how about this one? 3. So then we write -3 and then I. Because -3 is the real portion, I is the imaginary portion. So when we write complex number, we always write the real portion first and then the complex number, complex portion. If it's a radical, keep the radical later and then I first. So how about C? What two pieces you break it down into? Square root of what? -1 and 7. So what do we get from square root of -1? And how about square root of 7? Square root of 7 is not 7, right? We don't know what is square root of 7, so we bring it down. So if you don't have a perfect square number under the radical, it's not it doesn't become the whole number. It's not reducible. So you cannot reduce that. We'll leave it alone. How about the next one? Tarjun, the next one, go ahead. What happens to the first negative? We keep the same negative. And then we split that into what? We have -18, right? -1, definitely under 1. And then 18 is breakable, right? What two numbers make 18? 9 and 2. So when you have a number that is breakable, that is divisible by a perfect square number, break it down. If it's not a breakable, like 7, it's not a breakable number, keep the number. So 18 becomes 2 times 9, so we split into the square root of 9 and square root of 2. This negative stays same. Square root of -1 becomes I. What is square root of 9? 3. And do we know what is square root of 2? Radical 2. So we write -3i square root of 2. My MATLAB wants that, but it does look weird. So if you want, you can write -3 square root of 2 and then I. My MATLAB doesn't want that because people don't know how to write I after a radical. So if you put I after a radical, they consider this it's inside the radical, and which is wrong. So if you're writing on the paper, it makes sense. You can see it. But if you write it on computer, you don't know, did you write square root of 2i or square root of 2i? Which one? You don't know. Since you cannot distinguish that, so my method doesn't want you to have this problem. This is my MATLAB's favorite. I first and then the radical. Okay, now we are multiplying. We multiply exactly same as how you multiply numbers. The only difference thing is anytime you bump into I square, you must write it as -1. That's the difference between multiplying real number and imaginary numbers. You multiply same as real number, but every I square turns into -I. So let's follow these and do some example. If you're already directly given the I, you just have to multiply. But if you're not given I, you are given square root of negative number, then first you have to bring the I out of the square root and then you multiply. Okay? If you already see I, you can go ahead and multiply. If you don't see I, but you're given an unreal number, imaginary number, first bring out the imaginary portion and then multiply or divide. So here we can already see I, so we can go ahead and multiply. When you multiply, we multiply the number with the number, and you multiply I with the I, just like the variable we did before, the radical. We multiply number with the number, radical with the radical. So this is the same process. What is negative 3 times negative 9? 27. And what is I times I? I square. But what is I square? Negative 1. See, when you have two imaginary numbers, they turn into real number. That's something cool. One imaginary number is imaginary, but if you multiply two of them, it becomes real. So this is negative 27, the real number negative 27. See, we started with two imaginary numbers. When you multiply them, they have to become real. Anytime if you multiply two imaginary numbers, sorry, I shouldn't say anytime. Most of the time, if you multiply two imaginary numbers, they become real. In the next example, do you see I? No. But you do know that these two numbers are imaginary numbers. None of them are real, right? So since none of them are real, none of these are real. Since they are not real, so first you have to bring out your I and then you multiply. You cannot just multiply the inside. It doesn't make sense. We can multiply the inside only when you have real numbers. For imaginary numbers, you cannot multiply them. So take out the I. So this becomes square root of negative 1, square root of positive 2. 2 is real. This becomes square root of negative 1 and square root of 14. 14 is real. So this turns into I. We have no idea what that is. This turns into I. We have no idea what that is. And now we see our imaginary part, I. So we multiply I with the I. And we multiply real numbers with the real number. 2 times 14. When you have real number, only then you can multiply them inside the variable. But you cannot do that when you don't have the real number to begin with. So what is square root of, sorry, what is 2 times 14? 28. And what is I times I? I squared, that will turn into negative 1. Now 28, can you split 28 into, can you divide 28 by perfect square number? Like by 4 or 9 or 16 or 25. Can you divide 28 by any one of these? 4 and 7. And what is square root of? So you have square root of 4, square root of 7, negative 1. What is square root of 4? 2. Do you know what is square root of 7? No. So what is our final answer? Negative 2 radical 7. Now let's say you said, well, I don't want to do all of this. I just want to multiply the inside. Let's see what happens if you just multiply the inside. So you have -2 times -14. You decided not to listen to me and multiply anyway. So if you do that, you get square root of -2 times -14. What is -2 times -14? Positive 28, right? And this is square root of 4, square root of 7. So we get 2 square root of 7. Do you have the exact same answer? No. Definitely, this is wrong. So see, you get some result, but that's wrong. Anytime you multiply, especially in multiplication, in division you can cancel them. But in multiplication, you must bring out your I first, and then you multiply the numbers. Why? Because of the I square. If you have two i's, they automatically turn into a real number. Now in division, you can do the same thing. You can first pull out your i's, and then you work with the numbers. So if you do that, we get square root of -1 square root of 90 and square root of -1 square root of 2. Now we don't even have to convert this into I because we can see the exact same two things, right? When you see exact same two things, you can always cancel them out. So it's I, but you don't have to write it because they cancel out anyway. So we get square root of positive 90 over square root of positive 2. What can you do next? Any idea? You can do so many things next. What is one of the many things comes in your head, Jeremiah? Divide them out. So we can put a big radical, and then we can do that, right? So what is half of 90? 45. Oh, it becomes a cool number, 45, a small number. But can you split 45 into two pieces? Can you divide 45 by a perfect square number? 9 and 5. And what is square root of 9? Do you know what is square root of 5? So, two imaginary numbers turn into real number. Any question? Now we are going to add and subtract. Well, all these examples we did so far, we had only one term, like square root of -90, one term, divided by square root of -2, one term. Or previously this one, square root of 2 times square root of 14, one term. So you only worked with monomials, one term by one term. But not always we have imaginary numbers as one term. Usually, imaginary numbers comes as a two pairs. Sorry, one pair, two numbers. So the most general case is we have a real number plus the imaginary number. This is the real format of the imaginary numbers. We call them complex number. In this complex format, A is the real number and BI, it means a real number times I. So this BI is the imaginary portion and A is the real portion. So a complex number has two portions, a real portion and an imaginary portion. And we can write any number as complex number. For example, the whole number 7 is a real number, but we can write it as a complex number as 7 plus 0i, which is the same format. So we can write any number using the complex format. Let me know once you're done with this. What's the next slide? Too complicated. So when we add and subtract, we add the real number, real parts with the real parts, complex part with the complex parts. That's how we add and subtract. That's the main idea. Anytime we add and subtract, add real number with the real number, complex part with the complex part, and then put them together. When you put them together, you're supposed to put the real number first and then the complex part. For example, here, we have a complex number 8 minus 9i, and we're subtracting another complex number 6 minus 5i. It's just like variable x. You treat I as a variable x, and then you do the exact same thing. But anytime you have I square, you have to make sure to turn this into -1. So anytime you subtract something, you always have to change the sign of the thing you're subtracting. So first step, the negative sign turn into a positive sign. So it's 8 minus 9i minus 6 plus 5i. So you combine real with the real. What is 8 minus 6? 2. And then you combine complex with the complex. What is negative 9i plus 5i? Negative 9i plus 5i. Negative 4i. And then you just put them together. Real number first, complex number later. And that's your answer. That's all you need to do. Combine real with the real, complex with the complex, put them together. Try the next one. And then one more. Oh, I actually changed this into something I forgot. Sorry. Let me look at the review sheet. What did I do? Oh, here. Negative 50, okay, negative 2 times negative 18. Negative 50. So this is negative 50, 2 times negative 18. Right? Let me check. Come on. Negative 50, 2 times negative 18. Negative 50 times negative 18. Yep. Okay. Himadri, no phone. Ready? What do you do on the first one, on the left one? What do you notice? Two negatives turn into positive. It's actually 6 plus -3 minus 7i. So we can ignore the plus sign. It's 6 minus 3 minus 7i. The real portion is 6 and -3. What is 6 minus 3? 3. And then we have -7i. That's it. The interesting one is the next one. We do know that we are dealing with two imaginary numbers, right? -50 and -28. They are not real. So anytime you're working with not real number, you always have to bring out your I, imaginary portion, from the not real number. So you split that into 3 pieces. One piece is -1, and the other 2 pieces, oh, never mind. Let me do it step by step. Step 1, you bring it into 2 pieces, -1 and 50. But you do know that 50 is divisible by a perfect square number. 25 and 2. So 25 and 2. And this becomes I. So I, what is square root of 25? 5. And do you know what is square root of 2? Square root of 2. So the -50 under the square root becomes 5i square root of 2. In here we have -1 and +18. So it's plus 2 times that, plus 2, plus 2, plus 2. This turn into I, but can you break 18 more? Which two numbers? 9 and 2. And what is square root of 9? 3. So we get 2 times 3, which is 6i square root of 2. And lastly, square root of 100, is it real number or imaginary number? Real number. What is square root of 100? 10. So we have at least one real part. 2 are imaginary, 1 is real. Now, can you combine these two? In order to combine, we have to have the radical part and the imaginary part same. Do you have the same I? Yes. Do you have the same radical? Square root of 2, square root of 2? That means we can combine these two coefficients, because we have square root of 2i same. So what is 5 plus 6? So we have 11i square root of 2. But if you want, you can write 11 square root of 2i. And then we have this extra -10. Let me write side by side. -10. Or 11 square root of 2i minus 10. Oh, sorry, we cannot write that. My bad, my bad. Because remember, the format for complex number is real fast and then the using number. So we must write -10 fast because this is the real number, and then plus 11 square root of 2i, or 11i square root of 2. Both of them work. But we definitely have to write the 10 fast because this is the format a plus b I, the complex format. Real portion fast and then the imaginary portion. Any question? Camila? Multiply, all of them are multiplication. Okay. Anytime you don't see a sign, it is always multiplication. You see here, we see a plus sign, that means you're going to add this and this. But between here or between there, we see no sign, means it's multiplication. And with this, we are done with addition and subtraction. Tomorrow, we are going to do multiplication and division. And reducing the power of I. Like if you have I squared, even if you have I squared, it's -1. But how about I cube, I to the 4, I to the 7, I to the 100? What happens in that case? We're going to learn that tomorrow. And tomorrow in your PLTL, make sure you bring your exam, because the PLTL will later go over your exam. Okay? So you can see what mistake you made. And if you did not receive your exam, you can come with me to my office and then I'll give you the exam. You have to come with me to the 6th floor. I forgot to stop.